Hello everybody, welcome back to another episode, just in YouTube, I guess. It's not Minecraft. In this one I wanted to show you a kind of cool little math problem that I was doing the other day, and I'll show you how to do it as well. So you have a coin, and its diameter is d, and a grid of squares where each square's sides are of length d, like so. So if you flip the coin onto the grid of squares, what is the probability that the coin will cover one of these vertices, one of these crosses of two lines, or the meeting point of four squares? So to solve this problem, we're going to find the area within which the center of the coin can land. Where if it lands in that area, it will cover the one of these crosses, one of these vertices. So if you look at this circle, it's got a radius of d over 2, and that means that if the center here is anything less than d over 2 units away from the center point, then that means the coin will cover the center point, because the side of the coin will reach past it, because that's what the radius is. So if you take that and draw a circle around the center point of that radius, if the coin lands within this area, it will cover the center point. Now we've found the area around this center point, but there are several more, and so we need a circle around each of these as well. And I'm not going to draw it so perfectly because paint does not provide a perfect tool for this, for drawing quarter circles. So these are all the areas around points where the center of the coin can land and cover an intersection. If it lands in one of these other ones, then it will not. It will not cover any of these intersections. So we now have an ability to figure out the area here and the area of the whole thing. And since the probability of something happening is the number of ways it can happen that way, say 9, over the number of ways anything could happen, say 10, then the probability of that happening is 9 out of 10. 9 ways for it to happen, 10 ways it could have happened. So randomly, it'll happen 9 out of 10 times. That means that since the center could land any of these places on this grid, the number of ways it could land within these gray patches over the number of ways it could land in general is going to be the probability of the coin covering one of the vertices. So the area of this is going to be equal to the area of some number of circles of radius d over 2, and we have 1, 2, 3, 4 quarters, so that's one circle, and we have one in the center there, so that's 2 circles, and we have another 1, 2, 3, 4, 5, 6, 7, 8 quarters there, which is another 2 circles. So the area of these shaded regions is is equal to 4 times the area of this coin, or area of a circle with d over 2 radius. So that's going to be 4 times pi r squared, or 4 times pi times d over 2 squared, which is going to be equal to 4 pi d squared over 4, and the 4's are going to cancel out to give us pi d squared. And the area of the not shaded region is going to be equal to the side length of the the area of the square in total is going to be equal to the side length squared, which is going to be 4d squared, or 2d squared. And so the area, or the probability, is going to be equal to this number over this number, being the area of the shaded region over the area in general. The number of possible ways it could land in a way that will cover an intersection over the number of ways it could land in general, which is going to be pi d squared over 4d squared, or just pi over 4, which is approximately 78%. So then, that's the problem solved. Hopefully you enjoyed this episode. I know it was a little bit weird. I don't normally do this sort of thing. Let me know if you enjoyed it, though, because I could easily do some more of these, and I like math, so... anyway, hopefully you enjoyed it. Take care, and... wave. Bye-bye.